Hi, I'm Philip Vafiatis. I really like making things and I really like developing technology. I started my first business when I was a kid. I registered at 17, but actually started it when I was 15. And I love making things. And it turned out that after a little bit of doing that, I ended up loving making organisations that make companies that make things. And that's kind of where we're going to end up today, with something called the Innovise Institute that is something I co-founded and I chair. And I'm going to jump into the talk now, but it's framed around companies that we've helped grow. To start with, let's start with 3D printing. And we want to believe that 3D printing is going to change the world. And we'll get into that in a few minutes. But I just want to reflect firstly on Ping's amazing keynote earlier. And as she talked about a higher meaning, there was something more than just what we make. It was something about the purpose of what we make and the gravity of sustainability. So that's going to kind of be a theme through the next few minutes. Almost all good companies, in fact all good companies, get really good at iterative improvement. And that's essential because you've got to be more competitive, you've got to be more efficient, you've got to be more profitable, you've got to deliver better outcomes for your customers. And that's all through iterative improvement. But that's not step change. Step change is something fundamentally different. Let's come back to the 3D printing thing. Let's start with plastic printing. And plastic printers are getting fast, and they're starting to get reasonable scale. There's a couple of problems though. Plastic's kind of an evil on the planet. The Earth doesn't know what to do with polymers. They're only a couple of centuries old. The Earth takes a lot of time to actually understand how to deal with these things. And there are ways of minimizing that. You can take materials like silicon carbide and put it into the plastic to make it stronger so you can use less plastic. Now, that's not a solution. That's just slightly minimizing the problem. So, and governments around the world are starting to regulate the use of plastics because organisations like the Ellen MacArthur Foundation have been informing the world of the evils of plastic and how micropolymers are contaminating the sea, and it's a huge problem. So is that going to be the way that the world changes? Not so sure. Let's look at other things like printing metals. And I'm not going to talk about the welding processes that some machines have because they have problems that we haven't got time to speak to. Most metallic 3D printers are laser-based or electron beam-based. Basically, they melt metal powders to fuse together. That's what's been happening for 5,500 years. The Greeks figured out 5,500 years ago that you could dig up some dirt, you could extract some ore, you could heat it up and melt it, you could dig out a different type of ore, melt it, you mix it together, you've magically got an alloy, and if you want to give it some properties, you dunk it in a bucket of oil or water. That's pretty much how things still work today. Looks sexier today, software layers and all that kind of stuff, but it's the same 5,500-year-old technology. And that's a problem because heat brings problems with it. Heat means oxidation. Heat, metal, air means oxidation. Oxidation means glass box and inert atmosphere. And that means not big. Heat also means expansion and contraction. And expansion and contraction means warping and internal stresses. And mitigating warping and internal stresses means not fast. So how is not big and not fast going to change the world? This is a constraint of the fundamental physics. Everybody wants to believe that this future is going to exist. But the physics is a constraint to it existing. So there's this common belief, but it's not true. Now moving on. One of the companies that Innovise Institute birthed recently is a company called Titomic. I chair that as well. And we listed on the Australian Securities Exchange last year. And it's using a new type of physics to 3D print. We use something called kinetic fusion, where we accelerate metallic particles to several times supersonic speed. And we engineer an intersection between the particles to kinetically fuse them. And it's nearly a molecular level bond. And we can do it at very large scale, at very high speed, and with very high quality. So when we compare this against a decades-long journey to get from nothing to what GE launched last year and declared was the biggest laser-based 3D printer in the world at a cubic metre late last year, that's the entire history of laser-based things, a cubic metre. little, here. Titomic launched its very first step into the world. The tennis courts outside, add another 40%. That's our very first step into the world. That's a step change. So the physics was the constraint, even though there was belief that somehow it's magically going to grow. It can't, because the physics is a constraint. New physics means step change, and we're away. Now, let's come back to that sustainability matter. The world's got a real problem with waste, garbage. China just announced last month that it's not going to accept waste from other countries. It's been taking a lot of waste from a lot of countries. So they're pushing back onto every nation on the planet to deal with these issues. Wouldn't it be nice if there was it hasn't been possible to have a technology that can fundamentally deal with the majority of this waste. It can't recycle it. There's not one thing that can recycle most of this stuff. Well, there is now. We actually launched it we announced that company after it went through the Innovise Institute, and we announced that about 3 weeks ago in Australia, again at the Australian Securities Exchange, and that technology can fundamentally recycle nearly everything. Now, both of those companies were born out of our process, and it's a rare process. We built 70 companies to date, and those are just 2 of them. And being here at COFES is really remarkable because our process is unique, but it requires talent, and it's a collaborative process. Some of the things Ping was talking about as well. We have a different way of building these companies, and we've got great success. And on that note, I just wanted to say thank you.